Every single fighter jet tells a tale of ambition, risk, and the fierce competition that drives American air power forward. But behind the headlines and the legends of supersonic triumphs, dozens of prototypes rose on paper and in wind tunnels only to vanish into history's shadows. This is the story of every failed American fighter jet ever built, a journey that peels back the glossy veneer of military might to reveal the fragile edge where innovation becomes a sacrificial lamb. Imagine a world where speed alone was not enough. Pilots craved agility, endurance, and cunning designs to outfly, outmaneuver, and outlast any foe. From the early days of jet propulsion to the covert dance of stealth development, America chased the next great thing with relentless fervor. But for every F-86 Sabre that defined an era, there were the XP-79 Flying Ram, the XF-85 Goblin, and a parade of others that stumbled at takeoff, crumpled under testing, or simply stumbled upon a rival design that promised more and delivered less. Today, we peel back the covers on these mechanical ghosts, exploring why each daring concept failed, from underpowered engines and risky control schemes to crews left wrestling with prototypes that refused to fly. Along the way, we'll meet the engineers and pilots who trusted their lives to sleek fuselages and advanced alloys, only to learn that history favors winners, not the brave attempts that couldn't keep pace. So brace yourself for tales of machines that soared briefly, fell hard, and left indelible lessons etched into the annals of aviation. The roar of their engines may be silent now, but their impact still echoes in every modern cockpit. Today, this is not just a roll call of failures, it's a tribute to the spirit of invention, a reminder that progress demands sacrifice, and that every blueprint carries the potential to reshape the future, or disappear into the wind. History's hidden prototypes await our scrutiny, each one carrying dreams of breakneck performance and the promise of air superiority. We'll trace their lineage from secret war rooms to the hush of abandoned runways, uncovering why a turbine could outpace power, or why an airframe couldn't handle the stresses of high-G maneuvers. Prepare to witness cancelled contracts, lost pilot testimonials, and the ticking clock of projects that ran out of funding or technical viability. These are the untold stories that shaped the skies above, each failure a stepping stone toward the jets that followed, the agile F-16, the legendary F-14, and the cutting-edge F-22. In the high-stakes arena of defense innovation, nothing is guaranteed. A single miscalculation can send a project plummeting, but every setback refines the next breakthrough. So strap in, hold tight, and watch as we chronicle the birth, demise, and legacy of America's most ambitious, most ill-fated fighter jets. These machines may have fallen, but spirit endures. First, the consolidated Vultee XP-81 emerged from the twilight of World War II with a bold promise. A hybrid propulsion system combining a turboprop for endurance and a jet turbine for bursts of speed. Designers envisioned long-range escort missions where a single aircraft could switch seamlessly from efficient cruising to rapid interception. In practice, however, the turboshaft underdelivered, leaving the propeller starved for torque, while the jet turbine, set too close to the wing root, cooked airflow and sputtered under high demand. Pilots reported a bizarre yawing motion when throttling between modes, as if the aircraft itself were debating which engine to trust. By the time engineers recalibrated the fuel, air mixture and rebalanced the center of gravity, the war was over and purer, more powerful jets like the F-86 Sabre had already stolen the limelight. The XP-81 quietly slipped into storage, its lessons surfacing only later in dual propulsion experiments. Next, Northrop's radical XP-79 Flying Ram dared to overturn fighter design by putting the pilot in a prone position atop a wide, ram wing platform. By lying flat, an aviator could theoretically withstand higher G forces without blacking out, while the broad wingtip structure looked ready to slice through enemy bombers. On its maiden flight, however, the XP-79 demonstrated why big ideas carry big risks. A phenomenon known as aeroelastic flutter began to rip through the wing at just 300 miles per hour, turning solid aluminum into a springboard of chaos. The prototype disintegrated mid-air, the test pilot ejected with seconds to spare. Investigators later confirmed that the wing's torsional stiffness had never been fully modeled under dynamic load. The flying ram's destruction taught engineers a painful lesson in the unforgiving chemistry of thrust, mass, and material. Meanwhile, Bell Aircraft pursued its own dream with the XP-83, effectively a stretched-out P-59 Aerocomet packed with internal ferry tanks for transcontinental patrols. Designers bulked up the fuselage by nearly 30% and enlarged the wing root to carry more fuel. Yet bigger wings and fuselage translate into bigger weight, and the XP-83's twin-jet engines, recycled from wartime leftovers, lacked the sizzle to vault the airframe beyond 400 miles per hour. Test pilots likened its climb rate to that of a family sedan on a steep hill, with the Korean War underscoring the need for faster, more nimble fighters. The plodding XP-83 was shelved, its components cannibalized for training rigs and static displays. Perhaps the quirkiest contender was McDonnell's XF-85 Goblin, a pint-sized parasite fighter designed to nest inside the bomb bay of a conveyor B-36 Peacemaker. Imagine launching from a flying fortress, darting out to defend its mothership, then slipping back into a trapeze cradle for return, all without touching the ground. In theory, it was brilliant. In reality, turbulence generated behind the bomber's massive wings turned each docking attempt into a heart-stopping wrestling match. On 9 separate tries, pilots either overshot the trapeze, stalled in the wash, or experienced control link failures. After one particularly harrowing close call where a Goblin pilot clipped the Peacemaker's tail, the program was grounded. Though the Goblin never earned a combat stripe, its lessons informed future aerial refueling boom designs and even modern drone docking systems. Transitioning from grand ideas to brute firepower, Curtiss Wright unveiled the XF-87 Blackhawk, a twin-engine behemoth bristling with 420mm cannons and reinforced landing gear for carrier operations. Its team pitched it as the Navy's next big thing, promising dog-eating speed and long loiter times. During carrier landing trials, however, the Blackhawk's stall speed proved dangerously high, forcing erratic flares that shredded arresting wires. Above deck, its roll rate lagged competitor planes by nearly 20%, making it a sitting duck in mock dogfights. When the Navy finally contracted the more balanced F-4D Skyray, Curtiss's last-ditch marvel receded into obsolescence, leaving only flight logs and half-built prototypes as memorials. Shifting carriers and deck ramps, United States Navy prototypes embodied both boldness and bewilderment. The Curtiss XF Whitsun C blended a propeller up front with a turbojet in the rear, a hybrid design that attempted to hedge against early jet unreliability. As pure jets matured, this mixed approach looked more like indecision than innovation, and by the time landing trials began, the XF Whitsun C simply couldn't compete with dedicated fighter counterparts. Similarly, Ryan's XF-2R Dark Shark sought to pair piston power and jet thrust, but relentless vibration and maintenance nightmares grounded the program before it ever tasted combat. Grumman's XF-100F Jaguar promised wing versatility, variable geometry wings that could sweep back for speed or extend for landing grace. But mechanical complexity and hydraulic failures turned every flight into a test of nerves. The Convair F-2Y Sea Dart dove from jets into the sea, a seaplane fighter with retractable hydro skis. But excessive spray and gear vibration rattled airframes until landing tests resembled boat wakes more than smooth touchdowns. Douglas tried the sleek XF-5D Skylancer, an evolution of proven designs with advanced laminar flow wings and afterburning engines, and while it performed admirably, the Navy feared over-reliance on a single manufacturer and cancelled procurement. Elsewhere, Grumman's F-1 and F-1F Super Tiger shattered altitude records, but politics and timing relegated its triumphs to footnotes when the Lockheed F-104 Starfighter scooped up the big Air Force contract. Turning to carrier twins, the General Dynamics F-11B envisioned a long-range interceptor with swing wings and missiles, but added weight-produced, sluggish deck performance, and the Navy chose the storied Phantom instead. In the advanced fighter competition, Northrop's YF-17 Cobra dazzled with agility and lightweight, Yet operating costs and export rights steered the Air Force toward the cheaper F-16, though the Cobra found new life at sea as the FT-A-18 Hornet. Meanwhile, the General Dynamics F-16XL pushed delta wings and multitasking roles, but the prototype's unique shape proved too costly to integrate, and it bowed out to more conventional airframes. In a modern echo of old what-ifs, the Northrop YF-23 Black Widow II outpaced and outstealthed its rival in secret trials, yet the Air Force opted for the more versatile YF-22 Raptor, leaving the Black Widow as an enduring legend of unfulfilled promise. Boeing's X-32 attempted to engineer a jack of all trades Joint Strike Fighter, its bulky intake and stealth compromises hampering vertical landings and mission versatility, until the clean, nimble X-35 won the day and evolved into the F-35 Lightning II. Finally, private ventures like the Northrop F-20 Tiger Shark and Rockwell XFV-12 showcased the limits of market-driven designs. The F-20, a sleek export fighter, couldn't shake the F-16's political momentum, while the XFV-12's vectored thrust system never lifted it clear off the deck. Though none of these prototypes entered service, each failure forged new doctrines, refined materials science, and inspired generations of pilots and engineers, a testament that in the crucible of experimentation, every setback propels us closer to air superiority. Their dramatic failures fuel steady progress, proving that every prototype's fall drives aviation forward.